Hi. I've been watching a few of the videos by Steve Barton on his channel, which he does with his sons, and it's a great channel. I'm learning an awful lot about grinding, and there's some very interesting tool making and metrology stuff on his site, and seems like a really experienced and good toolmaker, and it's very satisfying tool making, and I've made quite a few tools over the years, but some of the things he's doing is really the next level for me. But I'm going to, as my precision over the years has got better, and my interest in metrology has got better, I have a yearning for doing things more and more accurately. Now, one of the things that Steve uses on his channel, which I like the idea of, was a depth gauge. Now, I typically use this sort of depth gauge, which I'm sure some of you do use, and you simply, it's the usual sort of micrometer thimble, and you wind it in, and this rod goes into the hole, and you can measure the depth of the hole. Now, these are fine, and they're good. I find them awkward to read because they read backwards. So instead of adding, you're subtracting on, and my mental arithmetic is not brilliant anyway. Secondly, I just find them awkward, to be honest. The other thing is that this is an imperial one. I've also got a Moore and Wright, which has is this a Moore and Wright as well? Yeah, I've got a couple of these. So this is the sort of like one that just kicks around in the shop, which I just use. I usually just set it to the height I want, the depth I want, and then just keep testing until I get there. But what Steve uses, which I really like, is an indicator. Now, he uses an indicator a bit like this one, which is a digital indicator. The nice thing about the digital indicators is that, first of all, they're very accurate. This is a Mitutoyo one, which I picked up pretty inexpensively, to be honest, and it's really accurate. I mean, obviously, to use this dead accurately, you would probably use it as a comparison measurement using gauge blocks on the surface plate or something like that. But for general purpose use, for measuring the depth of holes and slots and grooves and such like, this is great. And the other nice thing is, of course, a number of nice features about these digital ones. The first one is that you can also go into inches, so you can work in metric or in imperial. The other nice thing is that you can set them with gauge blocks or something, and you can press the origin button and they'll read zero, so you can basically read zero them at any position as well. So if you want to make something a step, or a series of steps and holes and things like that, this is much more versatile than an ordinary dial gauge, which you can zero but is awkward, and this is direct reading, both in imperial and metric. So that's I picked one of these up with the intention of doing this. Now, the commercially available ones are pretty expensive, and really all they are is one of these with a foot on it, but Mitutoyo seem to charge very handsomely, over £300 for one of these with a foot. Admittedly, it comes with a series of bars. Now, this came with one extension bar, so the normal this is it measures over 30 mil or so, but it did actually come with this extension. So there's the typical carbide ball end there, and then there's this 19 mil-ish extension which goes on there. So if you buy a Mitutoyo set of these, you get a whole series of these bars of different lengths to get you deeper and deeper into holes and whatever it is, keyways or whatever. So my intention is to also manufacture some of these little extensions, but more importantly, what I need to do in the first instance is make a foot. So effectively that foot, which this then mounts into like that, and then we can use it to set the bits and pieces. So this morning at the Auto Jumble, I was very fortunate to find a piece of gauge plate. There was a guy selling, he just had a load of junk really, but on his table there were two pieces of gauge plate, which I'll show you them both. There was that one there, which is 10 mil piece, and there was this one piece here, which is a 20 mil piece. I've ground and nice looking steel, 20 mil. Believe it or not, he wanted £1 for that and £1 for that, so I got them 2 for £2, so you can't complain at that. This is going to work perfectly. So what I'm thinking is that this is probably about the right thickness at 20mm. I mean, it might need to be just flattened down a bit, but that's about the right width as well, as you can see there, which is the 50mm width. So all I'm going to do is cut a piece off here, and then what I'll probably do is do something along these lines. So the top bit will be like that, and I'll probably just do a shoulder just to sort of lighten it and make it a bit more useful, and then so I'll be cutting a piece off a bit like that, and then we can just machine these in the mill. In fact, I might saw them first and then finish them off on the mill, and then ultimately obviously then we need a hole for this shaft here, and we need a hole. This is an 8mm shaft, so we'll drill and ream that, and then this is a 5mm shaft, and the Mitutoyo has a 6mm hole which goes. So the 6mm hole will go right the way through, and then there'll be an 8mm hole at the top bit here, and it's held in with a little set screw on the Mitutoyo unit, so I'll do the same thing. And then ultimately I'll probably try and harden this, because it is gauge plate, so it will harden. And then I'm going to grind the bottom and then lap it. So because again the Mitutoyo one very proudly says that it's micro lapped. And I've always fancied well, I've done quite a bit of lapping now, but fancied doing something very flat, and hopefully we can use an optical flat to see how flat we get it. I think I can't remember how flat. I think the Mitutoyo one's flat to within 2 microns, but whether we'll get to that or not is very unlikely. But at least we'll have a reasonably good version of this, and hopefully relatively inexpensively. Well, £1. Oh yeah, they were both £1. I think they were. Yeah, they were £1. So I'll still have lots left for making. I could make loads of them. Who knows? Someone else might want one. So first things first, a few measurements, a little bit of a chicken sketch, and then over to the bandsaw, and we'll chop some of this off and try and chop out the worst of it, and then we'll get on the mill and mill it and work from there. So I'll see you at the bandsaw probably. First things first, I'm going to square the block up. So start off with this side. I'm using a carbide tipped end mill here, so we should make reasonably light work of this, but this is all very uneven, so the whole thing needs squaring up. So I'll do the top first, we'll flip it over, we'll do the other side, then we'll do the two sides, and then all of 4 sides, measuring sides, should be true to the world. I'm just going to wipe the oil off the lovely Bridgeport constant loss oil system, which comes out the bottom of your spindle every time you use it. Right, so I suspect we need 800-ish speed for this. Let's just it helps if we turn the mill on. Right, can you guys see okay there? I think you can. Does that look about right? It does. Yeah, we'll see how we get on with that. Let me just wind up. We'll just get close and see what that looks like. That's clearing there. So we'll just go for a touch off around there and see what happens. So let's wind the knee up until we get a touch. Eventually. It always takes longer to touch off than you think. Come on. took some getting through, didn't it? But I think we got there eventually. And it's flat at least, so let's turn her over and do the other side. Right, just clean these parallels out now because we'll need it to be flat on there. Just deburr the edges so they don't stick in the vise. We need it to be straight with the world. So okay. Right, nothing's sticking up there. So that side now goes down, so we do that side, and then once we've got those two parallel, we can do these perpendicular then. So that side down. I'm just going to get a cloth and wipe these out so that there we go. Make sure there's no chips in there. Clean the part, make sure there's no chips. In she goes, up against that side. I've got the right side, haven't I? Yeah, that's the sawn side. So that goes on there. That feels sturdy in there. Now I can give that a tappity tap tap. Just going to use a... when you're doing the side, when you're obviously doing, this side hasn't been milled yet, so you can use a ball peen hammer. It gives it a better shock there. There you go, and that's definitely down now. I can feel it. So that's not much tighter, but that's obviously as good as it gets. Right, let's do this side then. Right, back on the. Okay, right, we're going to do this the ends now. So just cleaned up all my vise and everything, just cleaned the parallels, wiping them down with my fingers because you can feel any bits and pieces, because we're looking for something quite accurate here. So that's my sort of reference side, that one there, so I'm going to put that to the back of the vise, and then I'm going to true this edge up to the back. So let's just get this in there, set in the vise correctly. So that's in there. That sounds okay. Parallels are rigid under there, so that's nice and tight in there. So I think we'll just go along and do that edge square. Now the other thing I want to do is take away this corner, so just to lighten the thing up a bit, and I could do that with I might do that. I'll tell you what, I'll neaten up the ends first, and then we'll get a measurement, get it to a size, and then we can do the corners at that point. So let me just go and get a cutter and we'll come and bring you back. Okay, I've got that side, so we're going to do this side now. Let me just wipe this out. Watch that cutter with the back of my hand. Those bastards will have it. They really will. There we go. So that's down. Let me just tighten it up a bit, and then we'll give it a tappity tap. Okay, and let's go. So not quite touching, which is no surprise. Slightly better finish. Right, that looks nice. Yeah, that's a nice job. Right, that's pretty good. It's not a bad finish either. I mean, it is for a roughing mill. It's not bad at all. That's taking shape now. Let's take it out and have a clean up and see how it looks. So this next section, unfortunately, the audio went awry. So what I'm doing here is drilling and reaming the 8mm hole. There's also a 6mm hole as well. Now, before I could do that, I needed to find the very centre of this top section. So I used the edge finder to front at the back and then at the front. My DRO has a midpoint feature which is very useful. So all you need to do is find both edges, and the second one you hit the midpoint, it does an automatic divide by 2, and then tells you where the middle is. There was a little bit of doubt at the end there about whether it was in the middle, but I did a sanity check with my small scale just to make sure that it was in the middle. Which right, what we're going to be doing here is rounding this corner over, and I'm going to do that using one of these, which is a corner rounding mill. As you can see, it's got a profile which is about the right radius for here. So let's get this into the. I wind the carriage, the x-axis, so that it's just touching on that corner. You can see there where it's on the corner. So that's the deepest I want to go. So what I do is I set my I basically set my quill at that point there, and then using the knee, I just I zero my knee obviously, and then I just wind up with the knee to about there, which is like the highest point, and then I do the same thing with I'm moving on the cutter till it just touches, which is there, and then I zero my x-axis on my DRO, so I know how far across to come. And then what I do is that we'll start in the middle somewhere there, and we just come down until we touch off, and then we start making sweeps across. So if I just move you back there slightly, hopefully you'll get a good view of it from there. Right, now I've got the got my shoulders done, and and I've drilled and tapped the hole for the, which is 3mm, for the thumb screw over to the lathe, and we'll make a thumb screw. So I've got a bit of brass here, which is ideal. Just going to nail it, turn it down, put a thread on it with a die, part it off, pop jumper. So use a collet chuck. This is a 5/16 collet, 5/16 brass. To get it to start is I lock the tailstock down, I drive onto it, and then once it's taken, which it has now, the tailstock's just been pulled along on its own, and you see that it's drawing in, so it's actually just cutting the thread now itself, and once it gets to the this bit here, which is probably enough about there, we'll just stop it and back it off. If you need it to go deeper, you just do it with a hand, the hand die holder. But actually I think that'll be okay, because I designed it just to stick out slightly of that shaft. So I just want to make it so that it just clamps down lightly on the shaft of the... I'm just pulling back on the tailstock now, so it comes away, and there you go. There we go. Pretty nice. Let's go and try it for size as well. What I wanted to do is just principally check that everything is square and flat and all the rest of it. So the first thing I'm going to do is just make sure that that this surface and this surface are perpendicular to one another. So to do that, let me just clean this off. I can feel some bits on there. As you know, cleanliness is everything with this, so that's not perfectly flat. It's got a bit of a rock on it, which is not great, but if I hold it down, it touches on most. I'm going to lap that, so we'll probably get this flatter, but this is just to see in principle. So I have here my... Oops, let me just put it a bit further away. What I have here is my... that's the most square thing that I own, and this is dead square. I'll stick that on there. This actually rings to the table. It's that flat, well ground. So just to see if this is square, just to check my gauge, I've got the ball at the bottom here, and then the tip. And as you can see there, if I just sweep that in, that's 0 on there. You can see it's 0. Let me maybe just move you around here so you can see better the gauge. So if I put that in there you go, that's 0. So if I bring my part in now, again just clean the bottom of it, clean the surface plate, that feels good. We go up to there, and there you go, that's 0. And if I sweep across, there you go, 0, 0, 0, 0. Try it the other way around, and 0, 0, 0, 0. So that's dead square, which is great. You also find that the top's pretty good too. Let me just do the top. Let's just set that on 0. There we go. Let me just get that exact. Okay. So that's 0 across there. Let me just move it around here. It's a little bit low on that corner there, but actually that doesn't really matter. What matters is that ball there is parallel to this side here and this side here, and obviously perpendicular to the bottom. So to find out whether that's perpendicular to the bottom, what I'm going to do is, if I get this, I'm going to sort this out slightly. Right, there we go. That's 0. That's 0. That's 0. That's 0. Almost, and then a bit further in, and there's 0. So other than a little high point about there, that hole there is parallel to that surface, and that's perpendicular to that surface. So I'm pretty happy with that. This fits nicely into there, and I've still got to put a little set screw in there as well. That's the last thing I'm going to do before we decide to harden it up. So you can put it down on the surface plate like this, and you can zero it. So that's now set for 0. So not very repeatable. Probably the work, because this isn't screwed in yet, as you can see. But that's basically how it works. So I can measure. I mean, obviously with this tip on, I've only got a very short range, but by screwing these little shafts on here, you can zero it in any position you like. So if I just take this off, my intention is to actually make some of these shafts, and I'm also going to make some probes, because I find the Mitutoyo ones are eye-wateringly expensive, and all of the cheap Chinese ones don't fit the Mitutoyos, because they're all made for seem to be made for imperial micrometers. These are all M2.5 by 0.45 standard 2.5mm threads. So pretty easy to make, just in silver steel or something like that. So now that's obviously got a bigger range on it. So now I can calibrate it with some, let me just demonstrate. So that's a 900 gauge block. So basically, if you want to cut a hole 900 deep, what you do is you get your gauge block like that. You sit this down on top of the. Obviously, this is screwed down, so it works a lot better. But you sit that on your gauge block, like so. Can you see that? I don't know if you can. You then zero it, and now it's set. So I can go to a hole, and I can see how far off I am. So that's now set for 900 thou, which is 0.9. There you go. And I can test to see whether that's 0.9, and obviously at the moment I'm just testing my surface plate, but you can see that it's cock on every time. Hopefully you can see that. Let me move you down if you can't. That's about the way to go, actually. I think you can see it anyway. So yeah, go. Oops. So you make up your gauge blocks stacked to the distance you want, and then you can test your hole, and that tells you how far off from the desired depth that you're looking for. So I just got to tap a hole in there and put a little. I might make a little brass screw just to hold that shaft, and that way you can actually move it around as well. So if you can't see, if this won't fit in and you can't see it properly, you can swing it around. And I know that hole is perpendicular, so to be honest, you'd swing it around and tighten it, and then you'd calibrate it on the surface plate and then use it. But anyway, all that remains to do now is to harden this, and then I'm going to lap it to its final beauty. And if I can get finished like you do on a Mitutoyo gauge block, then I'll be very happy. There it is, the depth measuring, width measuring foot for a caliper digital indicator. Well, thanks for watching my little video about my foot, my depth measuring foot, and thanks to Steve Barton for giving me the idea, and I think this will be very useful. So see you on the next video.